So in this particular video, we will discuss about banking of the roads and how we can increase the speed of a vehicle when the road are banked. So what are banked roads? Banked roads में क्या होता है? The one side of the road is slightly raised, right? So the one side of the, I mean, if this is the lowermost point, then the road is raised up to point this. I mean, the road is slanted like this. So these are called banked roads, and in these banked roads, the speed increases compared to the road when it is flat. Okay, so in this particular video we will discuss the maximum velocity, how to find the maximum velocity of any vehicle on a banked road. So this is the equation and that we will be deriving. Okay, so in this particular diagram you can see a car which is running on a banked road. On a car there are various forces that are acting. The first force is mg, which is the weight of the car acting downwards. Now since the banking of road is done on the places where it is trying to take a turn, so when the vehicle is taking a turn, to increase the speed of the vehicle on a turn, the roads are bent. Okay, so if the car is performing a circular motion on a certain path of the road, then we have to bank a road, and then another region is performing a circular motion, and now when we talk about circular motion or circular path, then we talk about centripetal force, which is equal to mv square upon r. Now mv square upon r is the, which is what is r is the radius of curvature. I mean the curve is circular, so radius is r. The radius of that curve is r. Okay, so the first force acting on the car is mg. Now what is the second force? Second force is the normal reaction, capital R, which is called normal reaction. Okay, so we need a centripetal force which will help the car to rotate in a circular path, and also we have friction between the circular path between the road and the car. So in order that car completes a circular motion, it is required that the frictional force that is applied by the road is equal to the centripetal force. Then only a car will be performing a curved path, right? So basically we will resolve these components into perpendicular and parallel components, right, in x and y. So this particular arrow is the arrow of frictional force F, which is acting downwards, which helps in circular motion of the car, right? So if this angle is theta, this angle is also theta, then we have two components of f. One is f sine theta and one is f cos theta. So this component here will be f sine theta, and this component here will be f cos theta. Now here I have this arrow is called the vector of normal reaction. Here also we have two components. If this is angle theta, then this component is called, the component this one that is directing upwards is called r cos theta, and this component here again is called r sine theta. So in this direction we have two components, one is r sine theta and second component is f cos theta. In downward motion we have two components, f sine theta and mg, and on the above we have r cos theta. So we'll balance the forces, right? So from figure we can write r cos theta is equals to f sine theta plus mg, where f is the frictional force, f is frictional force, which is equals to mu s into r for maximum velocity, velocity to be achieved. Okay, so what we'll do in this equation, we will substitute the value of f equal to mu into s. So see, this is r cos theta, and on the upside we will equate these two forces, r cos theta, f sin theta, and mg, because they are acting in opposite direction like this. So we just equate this, right? Okay, so we'll substitute f equal to mu s cos theta. So r cos theta is equals to mu s r sin theta plus mg. Now from this equation, what can I do? What I can find the value of r. So if I find the value of r, then I will get r cos theta minus mu s r sin theta is equals to mg. So taking r common, I will get cos theta minus mu s sin theta, that is equals to mg. So r will be mg divided by cos theta minus mu s sin theta. This is equation number 1. Now we have equated two force vectors, that is r cos theta, f sin theta, and mg, which is acting downwards. Now we'll equate other forces as well, right? So we'll choose a yellow for this. So see, here I have f, here I have f cos theta, and the sum of both two will be equal to mv square by r. So we'll write f plus f cos theta. Let me write the component only. Wait. Okay, so we have the components are f cos theta, r sin theta. Okay, so f cos theta plus r sin theta is equals to mv square upon r. Okay, so here also I can substitute the value of f, that is equals to mu s into r, that is equals to mu s into r. Okay, so while substituting the value of f equal to mu s into r, we will get mu s into r cos theta plus r sin theta is equals to mv square upon r. Taking r common, I will get mu s cos theta plus sin theta is equals to mv square upon r. Now we'll substitute the value of r, that is from equation number 1. So we'll get mg upon cos theta minus mu s sin theta multiplied by mu s cos theta plus sin theta is equals to mv square upon r. Okay, I have this equation. Now I can cancel out m and m on both the sides. So let me write here, let me write on this side of the screen. Okay, so we'll get now r. So I have to find v, right? So to find v, let me rub this. To find v, I have to make v the subject. I have to make v the subject. So v square will be r into g mu s cos theta plus sin theta divided by cos theta plus mu s sin theta. So this is the value of v square. This is the value of v square. Now how I can simplify it further, right? I can, what can I do? I can divide both the denominator and numerator by cos theta. I can divide both the numerator and denominator by cos theta. So what will get? Dividing numerator and denominator by cos theta will get v square is equals to rg mu s cos theta by cos theta plus sin theta by cos theta whole divided by cos theta by cos theta plus mu s sin theta by cos theta. Now we'll simplify further. We'll get b square is equals to rg. So see, mu s, we have mu into s, which is the coefficient of static friction. Cos theta upon cos theta is 1 plus sin theta upon cos theta is tan theta, and in the denominator we have cos theta is upon 1 plus mu into s tan theta. So tan square is a v square equal to, let me write in the next slide, v square equal to, we get v square is equals to rg into mu s plus tan theta divided by 1 minus mu s tan theta. Okay, right, so it is clearly mentioned, right, it is minus, right here it is minus. Okay, so here it is minus, here it is minus, and here it is minus. Okay, fine, so we'll get minus, minus, and minus. Okay, so simplifying further, we get v is equals to under root of rg mu s plus tan theta divided by 1 minus mu s tan theta. So what is this? This is the value of maximum velocity. This is the value of maximum velocity. This is the value of maximum velocity of the car on the banked road, right? It is the maximum velocity of the car on the banked road. So this is the final equation that we were looking for. So I hope you must have understood this. Thanks for watching. Keep learning.